All right, so today we're moving on to a transformation called a translation. So it sounds like transformation, but it's specific. It's a translation. It's when you slide or push or shift a figure from one spot to another without turning it. So you're literally just sliding it or shifting it around. So these pictures, okay, this is a pentagon. It's being moved to the right and down, or you can show it with one arrow. Same thing with this picture, okay, to the right and up, okay, or it's going up and to the right, however you want to look at that. It says every point of the original figure is moved in the blank distance and in the blank direction. So the word is same, okay, everything is the same, okay, and we call these transformations that never change size, we call them rigid motions. Okay, rigid meaning they don't change, and motions meaning they're moving. So they're moving, but they're staying the same size, rigid motion. So we're literally just pushing these around. Okay, so I know for me, I find translations to be the easiest ones of all because it's literally just counting boxes. I mean, you can use a rule, but literally just counting boxes in two different directions, or sometimes one. Okay, the translation notation is this big T with, there'll always be two numbers separated by a comma. The first number is where you move on the x-axis, so left and right. So let me just use a different color. Okay, so this first means because it's positive, I'm going to move right 1. And then that 2 controls my up and down movement, okay, my y-axis movement. So this 2, and because it's negative, instead of going up, I'm going to go down 2. So if the first number is positive, you go right. If it's negative, you go left. If the second number is positive, you go up. And then if the second number is negative, you go down, right? So if I'm looking at this parallelogram in the picture, and I'm reading this notation, 1, -2, that means I'm going to make every point go to the right 1 and down 2. So starting here, I'm going to go right 1, down 2. Right 1, down 2. Oop, I went down too many for that first one. So let me just erase that first one. Okay, and there we go. And then I go to these points up here, and I'm going to go right 1, down 2, right 1, down 2. Okay, and I'm going to connect. Okay, and you see that whole entire parallelogram shifted right 1 and down 2. Okay, this is called a translation. Basically what you're doing, if you look up here, this is the fancy way, the rule way, you take whatever that number was right next to the T and you add it to your X, and then the second number adds to the Y. So if you want to do it algebraically, you can, or with a rule, you can. Okay, so I mentioned this with the previous transformations. With a translation, these are the properties that are preserved, okay? Another word for preserved is an invariant, or, okay, it just simply means stays the same or doesn't change. So basically everything, if you look at these properties, distance, angle measures, parallel lines, collinearity, midpoints, orientation, all of that stays the same. Nothing changes except where it is on the coordinate plane. So the size stays the same. All right, so here, okay, we have this triangle ABC. I put in these letters and coordinates, and the notation is saying -4, 3. So we're taking every x, y, and we're moving it -4, 3. So we're moving, remember, the first number controls my left-right movement, and it's negative. So I'm going to go left 4, okay, and then the second one is a positive 3, and that controls my up-down movement. It's positive, so I'm going to go up 3. So I'm going to take every single point and I'm going to go left 4, up 3. So I'm going to start with A. 1, 2, 3, 4. 1, 2, 3. And I end up at the point 1, 2, 3, 4, 5, 6, -7, 1. I'm going to do the same thing with B. I'm going to count 1, 2, 3, 4. 1, 2, 3. Okay, and that's going to be the point -2, 2. I'm going to call this A prime, B prime. And then C is going to go 1, 2, 3, 4, 1, 2, 3, and we end up right there. I'm literally just counting boxes. So we definitely have to, especially I know this graph is small, you got to be careful when you're counting. Okay? And that's the point 1, 2, 3, 4, 1, 2, negative 4, 4. So we went left 4, up 3 in all of them. Okay? Okay, so these are just all the different ways to describe a translation. We're typically going to see either mapping notation or this kind of notation, okay? But all of these are pretty easy to understand, okay? If it's described, it will just literally say 7 units to the left and 3 units down. It's an actual description in words. The mapping is just saying take X and subtract 7, take Y and subtract 3. That means go left and down, okay? This notation, which is the notation you saw in the notes, okay? And vector notation, okay, vector is just the direction in which it's going. So if we go, let's say left 7 and down 3, okay, the vector is the total direction we're going, I guess you can say. But again, we probably won't see that very often. All right, so these are just a little bit more interesting only because I've added in some algebra, okay? So if this is completely over your head, okay, make sure you can get the numbers down. That's really important, okay? But for some of us, we like to go a little bit above and we like to try a little bit of, I don't want to call it a challenge because it's not that hard. This says, number 1 says triangle DEF with vertices D, negative 3, 5, E, 2A, 3B, F, C, comma, 4B. It says D prime is 1, 3 after a translation. So again, graph paper, okay, is definitely helpful here. Okay, negative 3, 5 is here, let's say, and 1, 3. So we have to figure out what the translation is, how we went right and down. Okay, you could also figure that out by looking at the numbers. Okay, remember, some of the notation just said to add and subtract y. So if I ask myself, how do I get from negative 3 to 1? Okay, I add 4. How do I get from 5 to 3? I subtract 2. So that's how I figure it out algebraically. So the translation is 4, negative 2. So we moved 4 to the right, down 2. Now it says to take E and do the same thing. So because I don't have that much room, I'm going to put the translation here, 4, negative 2, and then E prime, I'll put the final answer there, and F prime, but I'm going to do the work down here. So I'm going to take 2A and I'm going to add 4 to it, and I'm going to take 3B and subtract 2. I can't combine that or anything, so that's going to end up being my final answer. Okay, it's going to be 2A plus 4, comma, 3B minus 2. And then I'm going to do the same thing to my F prime. Okay, it's going to be C plus 4, 4B minus 2. I'm literally just taking this, adding 4, this, subtracting 2. Sometimes I can combine terms, so always look for that. Okay, so the same thing with number 2, okay? Pause the video here and try it on your own and see if you get the right answer. All right, so the translation rule is T2, comma, F plus 4. So all I did is I looked at my 3A minus 2 and I said, how can I get from 3A minus 2 to 3A? Well, if I add 2 to this, it will cancel it out and give me 3A. So I know I have to have plus 2. 3F plus 5, I say to myself, how do I get from 3F to 4F? Well, I add in 1F. And then how do I get to 5? From 5 to 9, I add 4. That's how I figured that out. All right, so go try the classwork and take a look at the key if you need to, and ask questions when you are physically in school, or if you're only virtual, then email me.